Good morning friends, and in this video we are going to discuss about the electric field. Now, what is electric field? Theoretically, it is defined as the space around a charged body where its influence can be felt. That is called as electric field. So you know that when a body is positively charged, then it has a space around it where if you bring another body of positive charge, it will experience a force of repulsion, and if you bring another body of negative charge, it will experience a force of attraction. So it means that you just consider the scene. This is also the materialistic behavior of the substance. Now just assume that you have a body. This is the body, and this is a good conducting body which has electrons are very loosely held, and this one is a good conductor, so this one can get charge easily, this one can transfer the charge easily from it, and this can also receive the charge. So this is the nature of the substance, but right now it has no charge, means Q is 0. It means the space around here does not have any electric field, means nothing will happen. Suppose if an electron comes here, electrons will not experience any force. If another charge Q comes, it also will not experience any force. But if this body gets positively charged or negatively charged, suppose we in the standard value we take it as a positive charge plus Q, then the space around it where its influence can be felt will be called the electric field due to this charge. And what will be the influence? That if you bring a body which is positively charged Q here, and another body which is negatively charged minus Q here, this body will experience a force of repulsion because this is positive, and the direction of that force will be just line joining these centers and in this direction, and the magnitude of this force can be given as F bar is 1 over 4 pi epsilon naught Q upon R square, and this is R, and the direction will be OA. And suppose if this I name it as O and this as A, then it will be OA, means from O to A. Now if this is another body which has a charge minus Q, so if I just try to connect this one, then this one will experience a force of attraction because this is negative charge and this body is positive charge, and the magnitude of this force will be given as F bar is 1 by 4 pi epsilon naught, and that is QQ over R dash square. So I call it R dash, and the direction will be from this to this, means like that. So suppose if this is BO, so it will be from B to O, and that is called BO bar. So since this is a positive charge, that's why it was experiencing a force of repulsion, and this was experiencing a force of attraction, and this is called, so just theoretically it is not only this, everywhere around this you have a space where if you bring any other body of the charge positive similar charge, then that will experience a force of repulsion, and if you bring a body of opposite charge compared to this one, then that will experience a force of, so this attraction, and this influence, this space around this body is called as electric field. In terminologies of the calculus, it is written as E bar is limit Q naught tends to 0 force over Q. So now this idea right now we are not taking into the consideration for sake of discussion, we will be only working on this theme. So just I have to remove this line, so just give me 2 second break, and so here I remove this extra part, and this is just a sensor direction. So okay, so now this one. So same way, if I try to find out the electric field of this charge, means electric field due to this charge Q, so I have to find E bar is F bar over this Q. You can consider this as the test charge, means by placing this charge Q we are testing this field due to this. So this one will become 1 by 4 pi epsilon naught. This Q comes down below this F bar, so become Q over R square, and the direction will be same as the force. So this is the idea of the electric field. Now to explain this, now suppose कि if you just look at this, if I draw a circle around this, and if you bring this charge here, then the force will be like this. If you bring here, the force will be like this. These are called electric field lines. Just to understand their nature, the field will be in this direction. This influence will be like this. But if suppose in the interior I have another charge, I take it minus Q, minus Q, minus Q, minus Q. So the force now will be acting towards the center. So to explain the idea of the electric field, this using the ideas of electric field lines, this proposition was made that if you have a positive charge, then electric field lines will emerge out of it, and if you have a negative charge, then the electric field lines will concentrate to this, means it will appear converging at that point. Now if you see, this is the circles, like suppose when you have a lamp, then the light spreads in all positive direction. Same way, when it is positive charge, then the electric field lines will spread around this, and wherever the field lines are closer, that field is called as stronger field, and where the electric field lines are farther, then that field is called as the weaker electric field. So now if I just suppose I have a rod, if you take a rod shape and place charge on them, positive, 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 and another one with the charge right here, negative, 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 then the field lines will start from positive and end to negative. These two are parallel to one another, so the field is uniform, and these are closer to one another, means that represents the strength of the field. And when you bring a positive, so it will start moving from here to here, and they start going to this. This is the basic idea and generalization of the electric field. So just let me clear the screen, then I'll discuss another case, that how you can find the derivation for the charge due to a concentric circle, or due to a ring, due to a bar, etc. Okay friends, so now in this video we are going to discuss and just we are trying to derive out the electric field due to a ring. This is a ring, and on its axis, this is the origin, on its axis, and this is the ring, this radius of this ring is R, and then on this ring a charge Q is spread. So I just try to make it look like a ring. So this is a ring, circular ring of radius R, thin ring. So this, don't get confused that this is a hollow ring or something like that. It is just a thin ring, and the charge on this is Q, and we are interested to finding out the electric field due to this ring at point P on its axis, because this OP is the axis of the ring, So here you see that the radius of this ring is r. Okay, so let me remove this. Don't ever consider this is a this has some width, because we are taking it as a thin ring, thin as possible. Okay, so here you just consider one element dl. Okay, now if this charge q is spread over the circumference of this ring, so the charge density, that we can call as the charge density, it is kind of linear charge density, that is q over 2 pi r. Means this charge q, small q, spread over the circumference 2 pi r. So charge per unit length, this will be coulomb per meter. And out of this we have taken just small tiny patch of the length. So the length of charge element, under consideration is dl into, you just multiply, so this is the length of the element dl. Now what will be the charge on the length dl? If the charge on the whole periphery, that is q over 2 pi r, then the charge on this element, then charge on element will write as dq, tiny charge, and that will be q over 2 pi r into dl. Now you see that when you, that this is so we consider this as the x, so you can assume that there is one y-axis going like this. So this is x, and the distance of this element is, because we are considering this element dq, so the element this here, this distance is r. So the electric field, suppose if I place a unit positive charge here, so it will experience a repulsive force in this direction, and this is my axis, x. Let me make it capital X. Okay, so this I call it as dE, means the small electric field due to only this part, only the part dE. So this I am calling it as dE. So you know that the electric field formula, you just saw that electric field E bar we write as 1 by 4 pi epsilon naught q over r square. So here our electric field, this is a formula, you can say, we will just try to derive some information, and we find electric field due to this charge is dE bar, when this one, and that will be 1 upon 4 pi epsilon naught, and q, what is the charge on this element? This part, so q upon 2 pi r into dl upon r square, that is small r square, and the direction will be along this. So direction I do not mention here, but direction is going along this. So this is the electric field due to time. Now we will resolve this field into two components. This is my P, one along this one, and that I'll call it as the electric field component along x-axis, and this is electric field along DEY. Suppose this angle is theta, then what will be the value of dx if you just drop a tiny perpendicular here? Then this component dex means the electric field component in the direction of x-axis will be dE cos theta. dE cos theta. How? Just you see that this is your dE, this angle is theta. So if you just drop one perpendicular here, and then apply trigonometry. So cos theta, cos for this, cos theta is adjacent, means this part is adjacent, so I call it as dEx. So adjacent dEx upon hypotenuse, that is dE. So if you compare, then you will find that the dE cos theta will be dEx, and this part is dEy. So dE sin theta will be dEy. So here we have the dEy, means that part is dE sin theta, and so dEy will be dE sin theta. Now just look at the symmetry of diagram, because this is a circular ring. So for every component here, there is one component here of the same length, so dl. So if you try to find the force due to this, so this will go in this direction, and that will be the electric field due to this element. So if you again resolve this force, then you will have some element, some component along x-axis like this, and the one element along y-axis that will go upward. Now you see that the horizontal component dE cos theta of this one due to this is coming in this direction, and the horizontal component of this one coming in this direction, and the vertical goes into this direction, and horizontal of this one also goes in this direction, but the vertical goes in this direction. So this means the sin theta component, means the vertical component of dl and this dl dash, they are same and they are in opposite directions, so they will cancel out each other, and you will only have the horizontal component. So resultant field here will be the dE cos theta. So that is our dEx, and that is dE cos theta. And now if you integrate the whole thing, then you will find your whole electric field. So what you get, that the Ex will be integration of dE cos theta. Now dE cos theta. So now what is dE cos theta? So this is my dE. So what I will get? 1 over 4 pi epsilon naught q over 2 pi r into dl upon r square. This is my dE part, and cos theta for this is opposite, this is adjacent upon this, so that is x upon r. So this is we are going to get. Now because since we are trying to find out the elemental form, so I'll take all these constant terms outside, leaving only the elemental differential part inside. So this will become 1 by 4 pi epsilon naught q over 2 pi r into x upon r cube and dl. So the integration, this is line integration over length this. So if you just divide this whole circumference, that is 2 pi r, into the large number of small patches dl, and if you finally add them up, then that will nothing but just circumference of this ring. So the integral dl over this length will give you just 2 pi r. So my relation will become Ex, and this is Ex is 1 by 4 pi epsilon naught q over 2 pi r cube, because I have already multiplied. So 2 pi 2 pi r is required. 2 pi r into x upon r cube into this will become 2 pi r. So here now you see our we are using 2 pi r. This should be capital R, and this should also be capital R. This should be capital R. This is also capital R. So now R and R cancel, and 2 pi cancel. So we get 1 upon 4 pi epsilon naught Q x upon R cube. This is the final expression for this, and this is Ex, suggesting that this one will only be acting along the x-axis. So now this is our final expression, and there you can see that this. But what is R? What is the relation between small r, small x and capital R? So you see that R square, because it is Pythagorean theorem, if applied, this is radius, this is perpendicular, so R is hypotenuse. R square is x square plus x square plus R square. So what will have, our whole expression now will become Ex equal to 1 over 4 pi epsilon naught Qx upon x square plus R square whole to the power 3 by 2. Okay, so this is your final answer, that Ex is 1 upon 4 pi epsilon naught Qx upon x square plus R square to the power 3 by 2. Okay, so now I think it's clear. I need to clear the screen so that we can find some other values based on this expression, that depending on the value of x, what will be the electric field and what will be the proper relation, because this Ex is a function of x. So how the Ex is changing with respect to x. So for that I need to clean my screen. Just give me. Okay, so we have the case study. First case 1. Suppose this x is 0. So if x is 0, means electric field, this point P will coincide with O. So P will come here. So now what you see, that you will get something like this, that this is your ring and you are trying to find out the field at this point. If you take this element and this element, 2 elements, this is my dl. So because of this I will have one component here in this direction, and because of this I will have another component but in this direction. They will be equal and opposite, they will cancel. For if you have one point here and one point here, then for every point, like the electric field, same magnitude, because the same charge is there and the distance is also, radius is same. So if this one will cause the field here, this one will cause the field there, so they will cancel each other out, and so their overall the electric field will be 0. And this is our elaboration. But if you see properly here, if x is 0 and you put the value of x 0 here, then this whole Ex also becomes 0. So Ex is 0. Now if the case number 2, if we assume that x is, this small x is much more than the capital R, like the axis is quite long, if x is much more than the radius, then we have this relation x square plus R square, where x is much more. So if I say that x square plus R square to the power 3 by 2, we have this one. But if x is much more, and then if I try to take the x common, so 1 plus R square upon x square, and this is x square which I have taken common, to the power 3 by 2. So x square over the power 3 by 2 will become x cube, and this will become 1 plus R square over x square to the power 3 by 2. So if x is much more than R, then 1 R upon x will be, R upon x will be very lesser compared to 1. So it's even smaller than 1 between 0 and 1. So it means this whole thing will be so small that we can simply ignore it, and then we only have the value x cube, because r square upon x square will become, like suppose if the r by x is less than 1, you know those quantities between 0 and 1, just like 0.01. So if you square it further, this will become 0.0001. It just decreases further. So this quantity you can ignore in this condition. So you will have only x cube. So your expression will become Ex will become 1 by 4 pi epsilon naught Qx upon x cube, that is 1 by 4 pi epsilon naught q upon x square. This is Ex. Now case number 3. Case number 3, we don't have any such cases related to this one. I'm calling as case number 3. But here we can say that what will be the maximum value of this expression. If you want to find out the maximum value of the electric fields, where the Ex will be maximum. Ex will be maximum. So those who understand the calculus, they know that the finding out the maximum value of a function, first we have to find dEx up over dx to check out that what will be the value of differential. And now you see this expression, so you can say that the q over 4 pi epsilon naught, this part is constant. Now we have to differentiate something which is x upon this, that is the u upon v form. It goes like that. First keep the denominator constant, x square plus r square whole to the power 3 by 2 into differentiation of x, that is 1, minus x into differentiation of denominator, this is 3 by 2 x square plus r square whole to the power 3 by 2 minus 1, that is 1 by 2, and into the differentiation of this interior, this will give you 2x upon r square plus x square whole square, that will become simply 3. And for maxima and minima, you all know that we have to set this value to 0. Then what I'll get, the numerator will be 0. So now just try to save your time also, and this numerator, so this 2 I cancel, and I write x square plus r square to the power 1 by 2 common. Then here I'll be left with x square plus r square minus, from here I have lost everything, I just have 3x square, this is minus 3x square equals 0. So this quantity, sum of the squares of the two positive quantities cannot be 0, so we have to target for this. So this will give you r square minus 2x square is 0. So x square is r square by 2, that is x is r upon under root 2. So the maximum value of the electric field will be r by 2. We have yet to find it. If you want to verify it further, then you have to go for the second differential test, and that is d square Ex over dx square, and you have to put the value of it. But mathematicians have proved already that this one is maximum value. So you can conclude here that at x equal to r over under root 2, the electric field will be maximum. Now you see, so if I try to plot this with x, and this is my Ex. Now just look at the case 1. So in case 1, at x equal to 0, the electric field is 0. So means my graph will start from somewhere, and then at maximum value, this is reaches the maximum value, and that value is x equal to r over under root 2, and then it further decreases and it goes like this, and later it will become parallel to the x-axis, become unchanged. So this is the nature, like when the value of x increases, then start from 0, the electric field increases from here, it reaches to the maximum value, that is Ex, and then after the maximum vanishing R by 2, it start decreasing. So this is the relation between this. Thank you very much. Just subscribe to our channel, and we have lot more derivations and important things come up next.